All right, welcome back. Hononegah Honors, Algebra 2. This is the review guide of everything that went through in 9.4 to 9.8, and this was excellent. This is one of the more challenging chapters. We always end with a really rough one. And so as I do this review, it's probably going to take us a little while to go through everything again. Um, this is the ending. This is the last test we'll have, and Ms. Kinsel and I are still writing that. I'm doing this video quite a bit beforehand, so we're still writing this test, so I'm not even sure how it's going to end up looking when we actually take it. So here we go. Graphing a trig function. So again, this goes back a little bit. Drawing a midline. 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. Now, the phase shift. Anything that's being added or subtracted changes the graph left and right. So instead of the middle being at 0, the middle in this case is pi over 4. Period length. Period length for a sine curve is normally 2 pi. And since there's nothing being multiplied to x, okay, there's nothing right here that's being multiplied to x, so the period length for this one is still 2 pi. That means each of these increments, I take the period and divide by 4. So that tells me how much I should add and subtract. So I'm going to add pi over 2 to the right, subtract pi over 2 to the left to get all my critical values. So if I add pi over 2, so I'm adding 2 fourths. So I'm going to add. So I get 3 fourths, 5 fourths, 7 fourths, and 9 fourths. That's adding pi over 2. Subtracting pi over 2. So I get negative, negative, and negative. And again, those of you that are fractionally challenged may struggle a little bit with that. But I added pi over 2 to the right, and I subtracted pi over 2 to the left. So that's all. The only thing that I've really dealt with is that. Next, it's a sine curve, and it's a positive sine curve. So sine curves start on the midline and go up to the right and down to the left. And I connect the dots. So I've drawn in a sine curve. Next, describe the midline. So the midline starts at -2. The number at the end being added or subtracted tells me where the midline is located. Then the number in front gives me my amplitude, how much it goes up and how much it goes down. So it goes up 3 and down 3. So there's our first one. Next one, we're going to do a negative. Always remember that because that always throws people off. A negative and a cosine curve. So first, draw in your midline. Tick mark in the middle. 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. Phase shift. So now notice that it's adding pi over 2. So I'm going to, negative pi over 2 is the shift of the graph. Period length is normally 2 pi. So this case, it's 2 pi over 3 because there's a value being multiplied. So the increment, I take the period length and divide by 4. So that becomes pi over 6. So those of you that are fractionally challenged are really not going to like this one. So I'm going to add pi over 6 to the right. And I'm going to subtract pi over 6 to the left. Now, if you're struggling, you ultimately need to make sure you change the middle to have the same denominator of what you're adding. So that would help some of you. So I'm adding pi over 6 to -3 pi over 6. So when I add 1/6, I get -2/6. And I get -1/6. And I get 0, positive 1/6. So there's to the right, adding 1/6 to the left. -4/6, -5/6, -6/6, and -7/6. So again, you may want to put that in the middle there to make sure you get a common denominator as you add. It's a negative and it's a cosine. Cosine starts off the midline, but this one's going to start off the midline below. And then on, off, on, off, on, off, on, off. Connect the dots. Describe the midline. And on the last one, I forgot to put the y-axis in, so I apologize for that, but I will go back and do it here in just a second. The midline's at 1, and this goes up and down 2. put in the y-axis. I always put in the y-axis. The y-axis is located wherever 0 is. So again, just kind of giving you a semblance as to where the y-axis would be located. Going back, the y-axis would be located in between the positive and negative. So I went back to the previous example. And that's it. Next one, I have a tangent. Draw a midline. 1, 2, 3, 4. Technically, you really only need to do 2 to the right and 2 to the left, but I continue to do 4 just because it gives a bigger picture. Okay. So now the phase shift for this one is pi over 3. So notice you're subtracting pi over 3. And now I have to get the period length. The period length is always pi for tangent and cotangent. And so then when you do your increments, you're actually only dividing by 2 and not dividing by 4. So again, those of you that are fractionally challenged here, this is not a very nice one. Okay, common denominator here would be 6. So this is 2/6 in the middle, and I'm adding 3/6 to the right. Okay, so I'm adding pi over 2, which is 3/6. So if I add pi over 2, I get 5/6. The next one would be 8/6, which is 11/6 and 14/6. Subtracting 3/6, I get negative 1/6, negative 4/6, negative 7/6, and negative 10/6. This is a tangent curve. All right, so tangent has an underlying. All the tangent, cotangent, cosecant, secant have an underlying curve that I have to worry about. Tangent is sine over cosine. So I need to do a cosine curve. Cosine curve starts off the midline. Notice I will not connect these dots. These dots are merely here so that I can figure out where the asymptotes are located. The asymptotes are always located where the underlying curve hits the midline. Tangent goes upward. So along the midline, along the asymptote, through the midline, upward. So tangent always goes up from left to right. Reminder that cotangent actually goes down from left to right. Midline, this particular midline is at 5. There's no number in front, so it's going up and down just 1. And I always like to draw in the y-axis. Again, gives me a reference as to where 0 would be located. So 0 would be located between the positive and negative there. Cotangent. Draw on your midline. Phase shift of negative pi over 6. 4 to the right, 4 to the left. Period length for cotangent is pi over b. So in this case, pi over 3, which means the increments in this one is pi over 3 divided by 2, which is pi over 6, which is nice in this particular one that we're adding pi over 6. So I'm adding pi over 6 to the right, which gets me 0, 1/6, 2/6, 3/6, and I'm reducing each one of those. Subtracting 6, and 5/6. Cotangent has an so I've done this one and I've done that one. And so just kind of keeping track of the things that you've done. Cotangent is cosine over sine. So sine is your underlying curve. So sine starts on the midline. Every time it touches the midline, you will draw in an asymptote. And then cotangent goes high to low. It goes downward from left to right. So along the asymptote, through the midline. Along the asymptote, through the midline. Now, describing the midline in this case is at 0 because there's nothing being added, and the amplitude goes up and down 4, even though it's not truly at amplitude. 0 is located on the graph right here, and so again, drawing in the y-axis through 0. So that is a cotangent curve. Secant. 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left. Now, this is challenging. This is a little more honors level. You are actually going to take out, like a GCF, the 3. So anytime there's a number in front of x that is inside the parenthesis, you're actually going to take that number out and get GCF. So the middle of this is actually pi over 12. The period length normally is 2 pi, so 2 pi divided by b. And so the increments in this case would be 2 pi divided by 3 divided by 4. So what I'm going to add each time is pi over 6. So I'm adding pi over 6 to the right, and I'm subtracting pi over 6 to the left. Those of you that are fractionally challenged, you're actually getting 2 twelfths. So if I add 2 twelfths, I get 3 twelfths, which reduces. I get 5 twelfths. So I'm adding 2 twelfths, 7 twelfths, and 9 twelfths. Subtracting, I get negative 1 twelfth, negative 3 twelfths, negative 5 twelfths, and negative 7 twelfths. And that's a 12, not a 4. All right. It is a secant curve. A secant curve is a 1 over cosine. So I need to draw a cosine curve because that is my underlying curve. So a cosine curve starts off the midline. Every time the cosine curve touches the midline, I'm going to draw in an asymptote. And then secant and cosecant go away from the midline. So it touches the underlying curve. So it touches the cosine curve and goes away from the midline. So it goes along the asymptote, touches, it goes the other direction. So it goes away from the midline. And it kind of looks like a parabola. It's not a parabola, but it kind of looks like a parabola. Describing the midline. The midline is located at 1 for this particular graph because we added 1. And since there's no number in front, it just goes up and down 1. Drawing in where the y-axis would be located. The y-axis would be located in between the positive and negative pi over 12. So that is a secant curve. And so the last one that I have to do is a cosecant curve, and it's a negative cosecant curve. We'll get to that in just a minute, but we got to remember that later. For some reason, it went blue, so give me a second. I'm going to switch that. Black. All right, middle is pi over 12, pi over 2. There's my shift. 2, 3, 4 to the right. 1, 2, 3, 4 to the left. Nothing being multiplied, so my period length for this case would be 2 pi. So now I take the period length divided by 4, and that's what I'm going to add and subtract. So I'm going to add pi over 2 to the right, and I'm going to subtract pi over 2 to the left. So if I add pi over 2 to the right, and again, just adding and subtracting fractions, subtracting pi over 2. That's a pi. It's a cosecant curve. A cosecant curve is 1 over sine, so my underlying curve is a sine curve, and the sine curve starts on the midline. But it's a negative, so it goes down instead of up. That is a huge mistake that many, many, many people will forget. They'll get the right asymptotes, but then everything's going to go the wrong direction because they forgot to do a negative. So cosecant touches the underlying curve and goes away from the midline. So it touches the underlying curve and goes away from the midline, kind of like a parabola. So now, the midline is at -1, and it goes up and down 5. So the number in front tells me how much it's going to go up and down. 0 is located right here in the middle, so I'm going to draw in the y-axis. So there's my graphing. I graphed all 6 trig functions. Describe. Now, we really didn't do much of this when we did the other videos, and I'm not sure why. Again, this is something that we probably need to tweak in the future, but again, describing the transformation. Anything that's multiplied in front is a vertical stretch or shrink. So in this case, it's a vertical shrink by a third. Anything that's being multiplied, okay, that is a horizontal stretch or shrink. In this case, because that number, it's the opposite, remember, of what you think. So that is a horizontal shrink by a half. And then this is a translation to the left, pi over 4. So again, just describing all the different things that could happen. Okay, you can do a reflection, you can do a vertical stretch or shrink, you can do a horizontal stretch or shrink, and then you can do translation left or right. And then if I put something at the end, that's a translation up and down. That changes the midline. So the next one, the negative sign means a reflection on the x-axis. The number inside, that's a translation to the right, pi over 2. And then this would also be a translation up 1. So again, we're just describing the transformation. This is very much like a parabola way back in the day. So again, each one of those means something. And I forgot one. I apologize. Vertical stretch by 4. I'm glad I looked at that beforehand. The 4, that's right there. I forgot to say that. So the reflection is the negative, and the vertical stretch is the number. Write the rule. So now they want me to do similar to what I did before. If I want to do a translation to the right, I want to replace x with x minus pi over 2. So I am going to replace the x. That's a translation to the right. And so then just the stuff that's inside the parenthesis, I would get cosine negative pi over 2 minus pi over 3. Common denominator would be 6. So that would be negative 5/6. So that is just the translation to the right. Horizontal shrink by a half. You're going to replace x with 2x. Leave it like this. I know in some of those, so we're going to write the f of x. It says write the rule for g, sorry. So g of x would equal. So replacing x with x minus pi over 2, and then replacing x with 2x. Translation 5 units up. So anytime I'm going up, I am merely taking the entire function and adding 5. So that doesn't change much. That's a pretty easy translation. I'd have plus 2. Now a vertical stretch by 4. This is harder. I'm taking the whole thing times 4. So you're not just sticking a 4 in front. It is going to be 4 sine of x plus 8. So that is one that a lot of people will get wrong because they won't multiply the whole thing by 4. All right, so now they're telling me one trig function. They're telling me where it's at, and they want to know the other trig functions. So now 3 pi over 2 to 2 pi is in the 4th quadrant, and secant is 3. Secant is hypotenuse over adjacent. So hypotenuse over adjacent, which makes the other side 2 squared to 2, and I probably should have showed my work. 1 squared plus x squared would equal 3 squared. X squared equals 8. Take the square root. I get square root of 8, which is 2 squared to 2, and it's negative because it's going down. So now sine. Sine would be opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So this opposite over adjacent. Cosecant, this one's not very nice. Cosecant is hypotenuse over opposite. So I need to multiply both top and bottom by the square root of 2, which is 3 squared to 2 over 4. And cotangent would be 1 over negative 2 squared to 2. So I'm going to multiply both top and bottom by the square root of 2. And so I don't believe the one on the test is quite that challenging, in which this one needs to be simplified. but ultimately you should be able to handle it. Simplify, and this is probably what's going to be on your test, to be honest with you, okay? Simplify means that I want to get this down to one trig function. When I am done with this question, I'm down to one trig function, one number, or a number times a trig function. That's the only thing I can have when I'm done. Well, I see three different trig functions here, so I'm going to start changing these into sines and cosines. So cotangent is cosine over sine. And I'm going to keep that as a sine. And secant is 1 over cosine. Doing a little fractional work here. The sine of x cancels with the sine of x. Cosine of x cancels with the cosine of x. And so the answer to this question is 1. Everything canceled out, and I'm down to one trig function or an integer. You're going to need to go back. You're going to have these identities sitting in front of you. This is a negative tangent. This is a sine. Sine shifted 90 degrees is cosine. I'm still not down to one trig function, but tangent is sine over cosine times cosine. So now these two cancel, leaving me with negative sine x. More simplified questions. I see a single on the bottom. I see one thing that I'm dividing by, one term, a binomial. So I'm going to take the top and split it into two fractions. And then tangent divided by tangent is 1. And 1 over tangent is the same as cotangent. And then that's a trig. That's a Pythagorean trig identity. 1 plus cotangent is equivalent to cosecant squared. Oh boy. I see a binomial in the bottom, and the binomial is not a Pythagorean. So I'm going to multiply by the conjugate. So the conjugate would be cosecant squared x minus 1 and cosecant squared x, excuse me, try this again. Try to start over. I'm going to multiply by the conjugate. The conjugate would be cosecant x minus 1 and cosecant x minus 1 or plus 1 to both the top and the bottom. All right, so on this one, I FOIL this. I get cosecant x minus squared x minus 1. And then I distribute. So I get sine x cosecant x minus sine x. There's that fraction. Second fraction, and I know I kind of bobbled that. FOIL, distribute. Sine x cosecant x plus sine x. Everything's going to start working out here, I promise. Well, I'm going to add these two fractions together. So the common denominator is cosecant squared x minus 1. This cancels, and so I'm left with 2 sine x cosecant x. Cosecant x squared minus 1. That is equivalent, it's using my Pythagorean identities. Pythagorean identity, cosecant squared x minus 1 is equal to cotangent squared. Cosecant x over cotangent squared x. Oh boy, it's still not done. Anytime I see cosecants and cotangents, I want to turn everything into sine and cosine. It usually makes life way easier. So now 2 sine x times 1 over sine x over cosine x squared sine squared. And you know what? I'm going to keep this as cotangent squared. I realized I actually don't need to do that. These two are going to cancel. So I'm left with 2 over cotangent squared x, which is equivalent to tangent squared x. That one's hard. That one is rough. Even an honors trig pre-calc student might have a little difficulty with that one, just letting you know. So probably won't do one quite that rough on the test. Not sure. But again, that one's pretty challenging. Verify. Again, I'm not really big on the verify questions because of what we're doing right now. So I don't know if I can move this. Nope, I can't. I just need to move it just a little bit to give myself some room. But I am going to do it. I see a binomial on the bottom. So I am going to multiply by the conjugate, which will create a Pythagorean I'm actually going to leave that. I'm not going to distribute. All right. So now secant squared x minus 1 is tangent squared x using my Pythagorean identity, which cancels out the tangent squareds, leaving me secant of x minus 1, which is what I was trying to prove, is that the left-hand side would equal the secant of x minus 1. One more verify question. If I ever see something in which I could take out a GCF, like I can take out a sine x from both of those. Well, then this is actually a Pythagorean. If you take 1 plus cotangent squared x equals cosecant squared, then cosecant squared minus cotangent squared is 1. And so then sine of x times 1 is just sine of x, which is what I was trying to prove, was that the left-hand side was going to be sine of x. All right, sum and difference angles. Remember, when you get a 12th and you're trying to find the exact value of a 12th, then you need to split the 12th into two things that you know, okay? 1/12 is equivalent to, I'll do 4/12 minus 3/12, which can be reduced into pi over 3 minus pi over 4. Now, go to your trig sum and difference questions. I got it sitting right here in front of me. So the sine of the first angle, cosine of the second angle, minus, you don't put the minus sign in there. The minus sign goes here. The minus sign goes in the middle. So cosine of the first angle, sine of the second angle. So now I have to draw pi over 3, which is a 60-degree reference angle. So 60-degree reference angle is 1 squared root of 3, 2. And then I have to draw pi over 4, which is a 45-degree reference angle. So now, using those two pictures up here, I'm going to do each of these. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine of the first angle there would be adjacent over hypotenuse, and sine of the 45-degree angle would be opposite over adjacent. Big finale now. Multiply, I get the square root of 6 over 4. Multiply, I get the square root of 2 over 4. And then combining that into one fraction is the square root of 6 minus the square root of 2 over 4. That is the exact value of the sine of pi over 12. Cosine, negative 5/12. So again, anytime I see a 12th, I'm going to split this up into two things that I do know. Okay, so this would be equivalent to 2/12. That's not a good example here. I need. Sorry, I'm back. Had a little degree of difficulty there. So we're talking about 4/12 minus 9/12. So again, two things that I can reduce. Always try to pick two things that you can reduce. So then cosine of pi over 3 minus pi over, 3 pi over 4. Using my trig identities, I have this cosine with a minus, so this is cosine of the first angle, cosine of the second angle, plus sine of the first angle, sine of the second. So now I'm going to draw both of those. So I need a pi over 3, which is in the first quadrant, 60-degree reference angle. And then I need to draw 3/4 pi, which is in the second quadrant, 45-degree reference angle, which is a 1, -1 square root of 2. So now, cosine would be adjacent over hypotenuse. Cosine of the second one would be adjacent over hypotenuse, which can be rationalized, sorry. Negative square root of 2 over 2. Sine of the first angle, square root of 3 over 2. Sine of the second angle, and I rationalize, is 1 over the square root of 2. Now, algebra. Multiply, negative square root of 2 over 4. Square root of 6 over 4, which is negative square root of 2 plus the square root of 6 all over 4. And I'm going to redraw that there. It's negative square root of 2. So this is the exact value for the cosine of negative 5/12. They're giving me a trig function and where it's located, and they're giving me another trig function and where it's located. So I'm going to draw both pictures. So A is located in the second quadrant and has a sine of 4/5, meaning the opposite is 4, hypotenuse is 5. So find the missing side. The second one is in the fourth quadrant. Cosine is 12/13, which makes the missing side -5. So don't forget the negative and understand which quadrant it's located in. Now, they're asking for cosine of A plus cosine of B, which is the cosine of A, cosine of B, minus sine A, sine B. So now, looking at each of the drawings, I'm going to actually write the fractions in. So cosine of A would be adjacent over hypotenuse. Cosine of B would be adjacent over hypotenuse for B. Sine of A would be opposite over hypotenuse, sine of B. So now, negative 36 over 65, positive 20 over 65, because you got a negative times or minusing a negative, which gets you negative 16 over 65. Tangent. Tangent is not a friendly one. So here we go. They're giving you the exact same picture. So I probably should have kept the picture from the last one, but I'm going to draw in the exact same picture that I had before. 12, 13, -5 for B, and then A was 4, 5, -3. So that hasn't changed. There's A, there's B. But now what I'm asking is different. So I've got the tangent of A minus B. Tangent of A minus B is the tangent of A minus the tangent of B divided by 1 minus tangent of A, tangent of B. So now, tangent of A. Tangent of A is opposite over adjacent. Tangent of B is opposite over adjacent. And then 1 minus tangent of A times tangent of B. All right, we got some algebra to work on here. I have -4/3 minus -5/12. So the -4/3 plus 5/12. Common denominator would be 12, so I need to multiply this one by 4. So I've got -16/12 plus 5/12. The top is -11/12. Bottom. A negative and a negative and a negative. So it's going to be negative 20/36. So 36 minus 20/36 is going to be 16/36, which reduces to, I take a 4 out of both the top and the bottom, be 4/9. So now, -11/12 divided by 4/9 is the same as this. I get -99/48. So again, you may want to use a calculator on that one. That one is challenging for sure. Couple more. I'm asking you to solve. So in the end, I'm going to have an answer here. But I have a sine of an angle plus a sine of an angle plus an angle. So I got to rewrite all of this out. So sine of the first, cosine of the second, plus cosine of the first, sine of the second, plus sine of the first, cosine of the second, minus cosine of the first, sine of the second. So all I did was write out the trig functions from the sum and difference. Now, these two are going to cancel each other out. One's positive, one's negative. And so the other ones are the same. So I'm going to add them together. So I have 2 sine of x cosine, and still this equals 0. I can figure out cosine of pi over 6. Cosine of pi over 6 has a 30-degree reference angle, and cosine would be adjacent over hypotenuse. So adjacent over hypotenuse. The 2's cancel. So I end up with sine x square root of 3 still equaling 0. Divide by the square root of 3, I get 0. And so now this is a quadrantal angle. I'm going to do the inverse sine of 0. So where is the y values 0? Well, here at 1, 0, and to the left at negative 1, 0. So what angle measure are we talking about? Remember, we're trying to solve this. What angle measure is this? That is 0, pi, and 2 pi. Remember the restraints from last chapter. Solving again. And it's a tangent. And so this is going probably above and beyond. But here we go. Tangent of the first plus tangent of the second. 1 minus tangent of the first, tangent of the second. And it equals 0. Well, let's talk a little fraction stuff. So now, if I wanted to solve, let's figure out what pi over 4 is. Sorry. Has a 45-degree reference angle. And so tangent of this is 1, opposite over adjacent. So tangent of x plus 1 over 1 minus tangent of x equals 0. Multiplying both sides by the denominator gets me tangent of x plus 1 equaling 0. Subtract 1, and now I'm down to a question from last chapter. Do the inverse tangent of negative 1. So where is tangent negative 1? In the second quadrant and in the fourth quadrant. And so what is that angle measure? You're talking about 3 pi over 4 and 7 pi over 4. So this is taking what we learned in sections 9.3 and just taking it to a whole nother level. So now we're including sum and difference and solving from section 9.3. And that concludes, this is the end. I know I kind of gave an ending speech in my last lesson in 9.8, but this is really, 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 really the end. And so take care. I wish you all the best. If I can do anything for you in the future, please let me know. And I'm sure Miss Kinsel thinks the same thing. And good luck, be safe, and hopefully see you next year.